Thanks, Richard. And yeah, I figured I'm first choice since I gave the talk last year, right?
Yeah.
So I do have a kind of randomly thrown together bit, but it's about things that I and many in this room have been really interested in the last probably year or two in dealing with lots of issues, and that's good, bad, and ugly. I think, Richard, that was your suggestion, was good, bad, and the ugly. So I went with the theme. But I also, hey, let's see here. Let's see if I can get this thing to work. Oh, there we go. All right, so here we go. So I looked this up. This guy named Maslow came up with this slogan back in the 60s. If all you have is a hammer, everything looks like a nail. And this is referring. I'm putting this in reference to the DNS being used to solve all of the world's problems. And I like a little bit of a. Let's see if we can get this thing to go forward. Let's see. I'll get used to this yet. Okay, if I just use the scroll wheel, this will do fine. So I got a little corollary on this, is that if you have a whole bunch of nails, of what looks like nails, then you're going to pick up whatever thing you have that looks like a hammer and start hitting them with it. And I think that's kind of where we are with DNS being used to solve lots of problems. And in some ways, the DNS is a really good tool for solving some of the problems we've got to deal with. And in other ways, it's a very horrible tool for solving it. So this is a little bit about me, which is really just here for posterity in the slides. And I actually talked to a couple of people who asked, what do you do? So I run a security company. I'll just leave it at that. And I'm on a whole bunch of industry organizations spending my time, instead of running a security company, trying to contribute to the cause, and which causes consternation for everybody else at the security company who wants me to actually be there doing work there. So that's what I do. So what I wanted to talk about is, really where we're seeing the application of using the DNS as a weapon, a filter, a protection mechanism, whatever you want to call it, in dealing with abuse issues or perceived abuse issues or issues that bother people. And just kind of putting this in a little context here, we've been talking about how do we deal with malicious domain names, host names, stuff on the internet for a long time, and people have dealt with them in various ways. Removed them. We try and get things suspended. We try and block things at firewalls. We try and block things in DNS. But as we've been doing all this for a long time, and the abuse continues. It gets more complex, and we've got malware is the real driver of these things today. And then we also have, after 2011, all these data breaches came to light. Not that they hadn't been going on before, but they're certainly being reported a lot more last year. And so you've got this idea of data exfiltration going on, where you have people getting onto networks. The security companies are calling it APT, Advanced Persistent Threat, which to me means a guy got on your network, you didn't catch him, and he's taking files off of it, right? And trying to keep from being detected, but that's being done. And we've also had this as we all know all too well, various governments around the world have discovered that this DNS thing exists, and things can be done to it to make things be different. And the big trade associations and trademark and content providers have discovered that the DNS exists, and things can be done to it to make things happen for their interests. So in the hammer and nail analogy here, what are some of the nails that you can pound on? And I've kind of got this in rank order, at least my rank order, of things that we might agree that look like nails that could be pounded on with the DNS. Malware control, command and control servers, or domain names being used for those. Phishing domains that are set up by the bad guys. Mule recruiting sites, or people doing money transfers that are illegal, things like that. Then you kind of get more into these are bad probably, but are affecting intellectual property. When I say IP in this particular talk, I'm talking intellectual property, not internet protocol for the most part. So it's, I guess, more of a policy talk than a technical talk, but we'll still get technical. But these are kind of things that people don't want to have happen and would like to make go away in some form of private action. And you're seeing that being portrayed in the DNS, or in people wanting to use the DNS to do that. And then you're also seeing, in extreme cases, people manipulating the DNS around national insurrections, right? We have people cutting off the internet in Tunisia and other countries, people messing with DNS in Iran, et cetera. That was brought up in a couple of other presentations, I think, earlier today. So you're seeing a wide range of different types of nails out there to bang on. So what's the hammer? Really, it's your recursive DNS server. And whether that's at an ISP or an enterprise or a government agency or your home router or what have you, that's the hammer that you're using to beat on the DNS. And you can do things like completely block a host name, basically say it does not exist. You can redirect them to something you think is more benign in some sort, or to some sort of place to do some sort of detection around, or to give some sort of warning to users and things like that. And you can also do it in your with some tricks to IP addresses you don't like that resolve to via reverse resolution. And you can do this through specialized name server hardware and some software add-ons that you can put onto standard recursive resolvers. The big game changer, I think, that we had was the release of bind RPZs, response policy zones. I'm going to talk a bit more in depth about that. But in general, this technology, this technique of using your recursive resolver to block and filter and do things with DNS is very akin to a firewall, right? So firewalls block and filter and change packets designed or that are heading for different ports or different IP addresses. Think of the recursive resolver as really a DNS firewall when you're using it to block and filter in this manner. Whoop. All right. So how do you use that hammer? Well, it's really easy. You preload the cache with the response you want it to give instead of whatever is out there on the big wild internet. Don't basically pay no attention to what the authoritative server says. You give it the answer ahead of time, and then keep that answer in the recursive resolver as long as you have that policy in place that you want to be using. We've done this actually for a very long time in some circumstances. You could think of enterprises splitting their DNS and treating different things differently depending on what they are. Some ISPs have, for a very, very long time, had programs to block known child exploitation domains in various countries. It's been one of those kind of unsaid but done things. And there's lots of ways to actually get the entries in there depending on what you're trying to do. And you can either put values in direct A record responses for give it an IP address, loop back, or some sort of server. Especially if you're if thinking about blocking malware, you might give it, instead of just saying NX to a malware CNC, you might say that's actually this IP address over here, and that IP address over there happens to be a sinkhole or something that you are running and trapping things on, and so that a machine on your network's infected. So it's actually very useful in that regard. I've seen some people do some stuff with CNAMEs that gets very ugly. When you start doing that can lead to some problems. But that's a possible way of doing it too. But the main thing you have to do is get a list of names and a policy you want to put around those names, and put that into the server. And RPZs make that trivial, secure, and very scalable. I'm going to talk about that a little bit. So this is, if you haven't read Paul Vixie's Taking Back the DNS thing on Circle ID, I've actually got the citation there. It's well worth the read. I don't know that I quite agree with him that most new domain names are malicious, but there are sure a heck of a lot of them that are malicious, that are registered. The kind of the result of the work that they did over at ISC on this was the response policy zones. And so for all modern versions of bind on the resolver side, you can implement RPZs, and there's lots of nice features in it, and I'm sure some of the ISC folks could go into more depth about that. And I think we actually talked about them last year, if I remember right, at the conference. I think Paul actually gave a presentation on it last year. But one of the kind of the key values here is that you can actually pull in multiple policy zones. So if you have your own list of things that you want to make sure always do resolve, for example, your own stuff, or your partner's stuff, or the government stuff that you have to deal with on a regular basis, you could put that in there and make sure it always goes through. And then you could pull in lists from security vendors, from free information providers out there, and pull in different zones, and that actually you can layer them on top of each other. So it's very scalable, and it all works over your standard, DNS updating technology, right? So you can do IXFR and actually update on the fly, which is great because that gives you a real-time kind of blocking capability within your recursive resolver. So it makes it very, very easy to quickly move things in and out depending on what the threats are that you're trying to protect against. Make sure that's the next one. Yep, there we go. So, great. You've got this. You've got a hammer, and you've got you can really apply things very quickly and easily to whatever kind of policy you want. So, taking a step back to thinking about this a little bit more, and what are the things you're trying to accomplish and why, and keeping that perspective is really important for understanding how useful this technology will actually be, and how people will actually take advantage of it that are on the networks that are being protected. So you got to ask yourself: are you an enterprise or a critical infrastructure kind of organization, a government agency, something like that? Or are you an ISP that has a wide and diverse customer base, for example, or a university, or something where you have a different kind of protection set, different kind of laws and rules you work under? There's the my network, my rules kind of thing you can get away with within the private sector, but that doesn't work so well when you're an ISP that's providing connectivity to a vast array of citizens and small businesses, for example. Who are you trying to protect? Are you trying to protect your own customers, your own employees working on your network? Or are you trying to protect the interests of the government that's telling you to do something, or the holders of trademarked and other infringed materials that are telling you to do something? Those are key questions to be asked when you're looking at this kind of technology and how effective it will be. Because it really gets back to this: what's the user incentive that's on the network? If you're working for a company that has sensitive, secret data, or plans for your upcoming acquisitions, secret blueprints or patents and things like that on your network, that's something pretty sensitive. You want to protect that at all costs, and all the people that are on the network are pretty well incented to keep that stuff well protected. That's what they do as a job all the time. People don't want to get their computers infected. I think that's pretty much a universal thing. No, people don't want to get infected with viruses and stuff like that. There's a few of us weird people that like to see infections happen and see what they do, but we do those on unprotected networks and have fun with that. I'm a parent, and there's a lot of other parents in the room here. We just certainly want to keep our kids away from some of the stuff that we see on the internet. I know some of the stuff we see as a security company on the internet, you really want to keep people away from if you can. But then there's other people who don't want to pay too much for music, at least what they consider too much, right? And so they're going to go and try and find ways to get that. There's people who want to, especially in the U.S., want to save a little bit of money on buying pharmaceuticals, and they're perfectly legal ones that just because of the ways the laws are in the U.S. they can't get for the cheap price you can get everywhere else in the world, or the ones that aren't quite so legal anywhere, right? So there's people who want to do that. There's people who want to view all kinds of material that other people may find objectionable and have laws or what have you against in that country. And of course, there's people who may not necessarily like their government and want to talk about that, and depending on the society, that may or may not be something the government wants to allow happen. And of course, we've actually seen the extreme in this last year of people actually trying to not just start a revolution, but actually run a revolution over the internet. So some pretty diverse set of things that people want to do. But we, kind of going down this gamut here, pretty much everybody in that top area on the network will agree that that's what everybody on the network wants to do. Whereas on the bottom, if you start putting restrictions on what people can do, they're going to try as hard as they can to get around those restrictions. And that's where I think a lot of the problems lie when you're trying to use this kind of technology. It's only as good as the alignment with the people that are on the network that are protected by it will have, because there's lots of ways to get around it. And that's my next slide here. You need to really have an alignment between the people running this technology and the people using it and taking advantage of it. There's lots of ways to get around the hammer that is the recursive server, because as we know, there's lots of other alternative DNS solutions available out there, very popular ones. Between Google DNS, OpenDNS, and a host of others, and if you can actually do, and I'll talk about that a little bit more in depth. But you can actually, if you're running a network, you can actually say, well, port 53 isn't available for you to go somewhere else. You have to use my resolver. Well, there's alternatives to DNS itself. And so in general, if you have an incentive for the people on the network to want to get around it, they will find a way. And they will find a website that will teach them how to do that too. It's pretty much out there universally how to get around some of these things. And it kind of, a worst case scenario that I see, and if we are misusing this technology to the point where people are starting to find alternatives, is that you end up with a lot of use of what I call unsafe DNS servers. People would be advertising, I'll talk a bit more about the legislation in the U.S., but if you are seeing people not able to use the DNS server they want, they will go to someplace else that advertises hey, come here and use mine, it's free. Free is what you pay for too, right? So you get what you pay for. And that you can certainly see scenarios where less than scrupulous people will be saying, use my free DNS server, and then on that server they will be redirecting you to lots of interesting things that you probably weren't aware of. We saw that in a way with DNS Changer, where people were actually, they didn't realize they were being redirected, but what was happening is they're surfing along just fine, but every other ad that they saw wasn't actually being paid for legitimately. It wasn't being actually run by Google, it was being run by somebody else. In a real extreme case, you can certainly see people, the case where you could end up with a split root. Now that's kind of really worst case scenario. It would be kind of more difficult to dial out. But if we start diversifying the way we actually resolve and deal with the DNS, it's not too much of a step from there to say, well, let's just use an alternative DNS. There's more than one way to do that. So that's kind of my general overview, and then I've got. I'm going to get into the theme of the second half of the theme, right? We've got two themes, hammer and nails and good, bad, and ugly. So I've got some various issues, and then this is really just to spur kind of some thoughts and conversation, because we wanted to have, one of the things Richard definitely demanded from me was get some thoughts up here and have a conversation about this. So hopefully we can do that. So the good, and so I don't have sound effects, but if you remember from the movie, and yeah, if there would be a really cool picture of Clint Eastwood, and actually there is. I've got one on here. Now the version that will be on the line won't have that, but so now how many of you have seen The Good, Bad, and the Ugly? All right, okay, this is a good crowd. So this is like my third or fourth all-time favorite movie. So I've seen it. It's a very long movie, but the themes that came out go throughout, I think, are actually fairly appropriate for what we have to deal with here. So I already talked a bit about this, but this is where I think you can really use this kind of technology extremely effectively, and we've seen that a lot of the bad guys are really doing just stupid stuff. Right? But we're not catching them. We're just not doing a good job of it. We're not doing a good job of getting information out to places that can actually use it. There's no pointer on this thing, but this one right here, right? This APT stuff. We've seen this over and over again, where there's something is dumb. And we've seen this passive DNS especially, but you can go and see it in the DNS logs from people who've been exfiltrated. RSA had this, right? They knew it was, you can read that in the report. That basically the name of the company that is having their data stolen from them is the host name that's tied to a domain name that the bad guy is running, and they're taking and just putting the data out to it. And as I said, duh. And it's like this is stuff that's trivial to block by just knowing what bad guy domain is, right? But that's actually, when you start thinking about techniques that bad guys use, they use things like fast flux. So your standard of being able to use the firewall, right, that's based on IP addresses and sitter blocks and port rules and things like that, doesn't necessarily apply because they can rotate IP addresses very quickly. Firewall rules don't get updated, not necessarily that easily. But if you know what the host name is they're using, done, no matter what IP addresses they're rotating it to, you can block it. And you've also got just case after case of the malware that's using either well-known and understood host names or DGAs, domain generation algorithms. So configure, right? We all know what the domains are going to be. So we made this big effort to go and block them from being registered. Well, okay, I could do that, or I could just put the list in on a daily basis of all the configure domains that are going to be in my recursive server and not go there, right? Or put it over to my intrusion detection system. That's actually a little easier than trying to get every registry in the world to block the domains. Of course, that's easy for one enterprise to do. It's not easy for the entire internet to do that. So, I mean, there's the counter argument there too. But if you're worried about protecting your users, it's a great place to go. So really, I think you can get a really tight protection scheme if you combine this with your standard firewalls and other anomaly detection on your network. You've got a really good way of locking down that kind of I kind of think of firewalls as body armor, and you can go buy more body armor and you can get more stuff to figure out the bullets are coming at you. But in the meantime, why don't you put on a helmet too, right? Which I'm thinking is the DNS side of it. Right? So that's just part of your security policy. In an enterprise, you can dictate port 53, right? So you can say everybody has to use this resolver. You don't have a choice. And even the remote users, you can force them to use VPN, at least whenever you can, when it's feasible. And there's tons of solutions available in both private sector and publicly available, open source, et cetera, to be able to use this kind of stuff. And once you lock it down and have the ability to be tracking this stuff, you can also take advantage of DNS logging, right? So either two ways of doing it is actually get the logs from the DNS servers themselves, which are a little hard to handle at times. The other thing you can do is install a passive DNS sensor on your own network, because that puts it out right in a nice, easy format that you can look at. And from there, do anomaly detection. So you've got a domain or a host name that pops up that you've never seen before. It's really odd. Might contain your brand name in it, for example, in that APT thought. And you could actually start tracking this kind of stuff. Other thing you might detect here, too, is something that it's not a whole lot of this is going on right now, but there's some DNS tunneling and malware command and control via the DNS. Right, so there's a couple of pieces of malware out there that use DNS for their command and control because, hey, everybody has to talk DNS. You can't block that, right? You can block IRC. In some cases, you can block port 80, especially on the inbound side. You can block port 80, but you can't really block DNS. So if you're actually got your stuff locked down, that's a good time. Then you can actually be logging this stuff and looking at it and looking for this kind of stuff in it. So it's a really, I think, a tight solution to couple together with all the other stuff you're doing to find this stuff. So the bad. All right, who remembers who played the bad? Lee Van Cleef. Very good. So then this is from the opening scene of the movie. So what would I personally put under the bad here? And I think most people here would probably agree with this, is that we've had some really nasty applications of this that have showed up in legislation. In the U.S., we had SOPA and PIPA. Those have been talked about a lot in various places, but I mean, whether or not we think this is good, bad, or ugly, I guess. Sorry, I didn't really mean to use that there, but it's something that it was fairly inevitable given the lack of progress we've had in dealing with abuse in the internet in general as a community. and it was almost inevitable that something like this was going to arise and we'd have to deal with it. Now, it's fairly dead now in the US. However, we have an election cycle, as a few of you may know, in the US right now. And I fully expect this stuff to come back in the next, once we have a new Congress set up. And I don't think it'll matter whether or not we have a new president or not. It's more of a congressional issue, I think. But it will certainly come back in some form or another. So that's not dead. But here we were being told that as part of this deal is that we're going to use DNS at the U.S. ISP level, recursive servers, and we're going to publish a blacklist, and we want you as an ISP in the United States to basically implement the DNS firewall concept, right? And we also had seen this elsewhere too. I know we had a good example in Italy. We've heard about. I don't know if we talked about that here. I've talked about, I've seen a couple of presentations on this where the Italians did basically a similar thing, and we saw there, I guess, a large-scale migration to Google DNS and OpenDNS and alternative DNS solutions. So not quite exactly what they wanted to have happen, I think. Now the ACTA stuff, in my reading of that's really a treaty about dealing with intellectual property, not dictating that people use the DNS this way, but Anonymous seems to think it is, and they've been going after anybody who was even thinking about adopting it. So there's a lot of, because of the SOPA and PIPA, I think we're conflating a lot of things in other countries as a result of it.
You can substitute Ireland there.
Ireland, yep, Ireland had one as well, and Poland was looking at doing ACTA, and then they got DDoSed, and so there's like some real world implications of people reacting to the thought of using the DNS as a hammer. And then, of course, there's some rather famous or infamous, or however you want to call it, use of national firewalls and filtering around the world in various countries, blocking various things. This is not uncommon for countries, and I'm not going to name any names, but I mean, we know various countries that do various things for different kinds of content that they don't want their citizens seeing. A lot of it's done in the firewall, but some of it's certainly done in DNS. And so that really has, if you're running a recursive DNS server anywhere, that has some implications, obviously, for what's going on, and real impacts on how you do things. And then as an authoritative provider of DNS servers, there's some implications as well, because you don't know what people are doing in transit to your stuff. We certainly saw, we talked earlier today about the DigiNotar hack and publication of false records for Google that ended up being that was done in the DNS as well. So there's a whole set of things that are going on that impact all of us, whether we're running recursive or authoritative or both. I went the wrong way there. Sorry. So I've talked about this a bit, but why this doesn't work in the ISP context is that really the users don't like it, right? It's in an enterprise, when you're trying to protect against the kinds of threats you protect from there, the users are in line. But in the ISP world, you have lots of people that have different interests, and there's so many ways to get around it. So I like to remind people, you could just go to the IP address, folks. DNS is a domain name, maps names to numbers. In the end, the computer connects one number or connects your computer to a number, not to a name. And in ISP, I shouldn't say most countries. I think most North American and European countries, at least, ISPs can't tell you what to do on port 53, right? It's an anti-competitive situation. I know talking to U.S. ISPs about this very issue. It's like if we start forcing people to use our DNS servers, we get sued out of existence by Google or OpenDNS, or have our regulators breathing down our necks on that one. And then, of course, DNS can be done over other ports and proxies if you get software to do that. And of course, on the web, you could proxy anything anyway. So you can go, if you're looking for web content, well, great. I'll just go to this proxy and just have it pull in the content and then shove it back to me. Then you just have to start, if you're going to try and follow through with this policy of blocking at the ISP level, then you have to block all the proxies. The proxies have legitimate uses, though, so it gets really hard to do this. And then the last point, which I'm going to transition to here, is that there's some issues with DNSSEC and that was certainly part of the testimony against SOPA and PIPA is that exact issue. And so, who remembers who played the Ugly, other than Richard? Yeah. It's Eli Wallach. Yeah. So, anyway, that's from the end of the movie right there at the graveyard shootout. I was going to put just the eyes from that scene, but it's harder to identify it. So, and I've had some arguments about this one. This is what I consider kind of ugly about the whole idea of using DNS firewalls with the current technologies. We've got a real issue with DNSSEC. I don't think this is an issue today because we're doing stuff at the resolver level, right? We're failing validation there. So if you're gonna give a synthesized response anyways, well, it doesn't matter if you're failing there. But as we move more and more towards endpoint validation, this becomes a big problem, right? Because endpoint validation says, okay, I just found out from my server that this doesn't work, right? I'm getting a failure because my recursive server is lying to me. It's telling me that it doesn't exist or it's at a different IP address than is actually signed in the zone. So I'm going to find some alternative way to get around that, and I know that's already being worked on as part of how people want to do DNSSEC at the end level, right? So you have a problem here where you're going to end up with, okay, my server lied to me, so I'm going to go find where it really is, and I'm going to go to that, right? So what I'm trying to do is actually block you from going to something you shouldn't because it's malware or something like that, right? So the whole thing it doesn't do what it's supposed to do. So really going forward, this needs to be, we need some sort of fix. I know there's been a couple of different thoughts about how to provide an extra reputation bit or some sort of thing like that, but we don't have that today. And it's an issue since a lot of us are trying to help get DNSSEC rolled out. At the same time, we're saying, hey, protect your networks. Oh, by the way, these things don't really coexist too well together. So I consider that kind of ugly as far as the situation goes. And I got the other. I don't have a person here. I was going to find something cool, but I just have the other. So this isn't necessarily good, bad, or evil. It's just things that I find interesting about this. And I had these slides for a different presentation. I thought this would be really appropriate to talk about in a little bit more depth because we're having, there's kind of the I don't know, the high-level discussion we can have about this kind of stuff, or we can actually take a look at an example of why it's far more effective to block things at the resolver than to try and figure them out and get them shut down. We've got, I want to talk about some complex kinds of things that are going on where the bad guys eventually have a domain name they're using that's infecting you. And we've got, I've talked a bit about this, but we've got a lot of techniques that people are using to hide from being able to be detected easily. So you see a series of spams where you get to one site and then it redirects you to another, and then through some obfuscation on that site, you eventually end up at the bad spot. That's what I'm going to talk about here. And you got DGA stuff that's going on. They're encrypting that now, so you can't just tell right away what's going to be happening. Lots of different cool stuff. We've seen the control panels in some malware families where they actually have their domain. Here's how you go to this registrar, registers this domain, it's all automated. It's beautiful stuff. They've done a better job than most registrars, I think, as far as some of the way they built the software. So the example I was going to show you, talk about, is what is probably hitting a lot of your inboxes today. If you're getting phishing, what looks like a phishing email from the IRS, the Better Business Bureau, Notcha. They've switched in the last couple of days to doing JP Morgan Chase.
Intuit.
What's that? Intuit, yeah. It's tax time in the U.S., so it's a great scam. IRS, by the way. So these really huge spam campaigns are going on using Cutwhale primarily, which is the big spamming bot now. A bunch of the other ones have been knocked down. They're spamming. They're sending a lure out, and what you end up with is a compromised site. Those redirect to another site. And then that site then uses a series of what's called black hole exploits. There's a couple other exploit kits out there that sometimes get used as well. And then basically, as soon as your browser touches that site, it checks to see what you're using, then fires the exploit at you and owns your computer on the spot. So basically, you click on the link, you're dead, depending on what you've got. So it's really hard to know, though, what domains are involved, because the spam has compromised domains in it, not registered domains, and those redirect. So here's what one of these looks like. This is a Notcha one. Okay, this is from a couple months ago, so it's gone now. But at the time, it was live when I first gave this. So this is what happens if you go to there, right? It says this page is loading. I'm sure some of you may have seen it. If you've seen this on a Windows machine, go get your machine cleaned. All right? Because what you end up with is, okay, there we go. It's a little slow on that one. Right. That's what you actually end up with. A white page, but in the background, that's what's happening. So, and this is what it looks like, kind of in the source. There's a hack server, and it's got all of these things in it. Because what they've done is they figured, well, if I do one redirect and they shut this down, then I can't get there. So they do 5 different ones. So your browser's going to try and load all of these, right? It's brilliant. So you go to one of those. So here's the first one. And that actually is going to take, that has only one thing on it, right, which is this. So Hackaboat. I like that domain name, Hackaboat. And then that domain is, this was the one the bad guy actually has registered, right? So, and if you type in that URL, you actually just end up at Google. It just redirects you. You have to actually come through the redirection chain in order to actually get this, right? And eventually, this one would download Zeus, right? But they changed that up. So there's CreedX and some other stuff that CreedX or however you pronounce it, gets downloaded as well.
Was it downloading Zeus or downloading the PPI dropper that downloaded Zeus?
That's a good question. It was getting Zeus actually directly on that one, if I remember right. But you know, it's whatever technique they're going to get. There's basically guys paying the guys who are sending the spam to send the spam. There's other guys paying the infrastructure guys who are running the thing, and then whoever the malware guy is, whichever one they want to drop on you, they're renting the services of these other guys in order to do this. It's like 3 or 4 different organizations, so to speak, that are putting this all together. And if you know the name Paunch, that's the guy who's writing these exploit sites. But this is what it looks like in the exploit site, and this has changed since then. But it's basically, if you go there and just look, take a look at it, this is what it looks like. So the bottom line here, and I didn't separate this out. If I go to a registrar and say shut this thing down, that's hard, right? Because they have to understand that you got to redirect through all this stuff in order to get to this. This code here is going to do something really nasty to somebody's computer if you actually get to it, right? So that is hard to do. Now we do that on a daily basis, try and get this kind of stuff shut down. But instead of that, well, in addition to getting it shut down, because you want to protect people, those domains are really well known, right? This Hackaboat, that gets out there pretty quick. So you can actually add that to your DNS firewall. And what's even cooler about this particular stuff and using a firewall approach, so basically you can get the lures will go out, the users will click, whatever, because they always do, they're users. They'll end up getting redirected, but it won't be there, so they won't get infected, right? So they'll just get the loading page and nothing will happen. Cool. But what's cool about this particular kind of attack, and lots of others like it, is that for the most part, we know what the domains they're going to be using tomorrow are. Right, so I can preload those in the servers, because either through passive DNS monitoring, because they do a whole bunch at once, looking at what gets set on various name servers, they keep using the same name servers over again, or looking at registration data for domain names, like who the registrant is or the emails that they're using. You can actually predict a lot of this stuff. Yes.
Why do you think they're using names instead of addresses? Like, why use Hackabout and not just...
Oh, because they can move it, right? So because you can call the hosting company where it's actually hosted. Yeah. Those are actually a little easier at times in getting the domains shut down, because they use registrars. Well, in this case, they're actually using registrars that are fairly easy to get them shut down once you actually let them know who they are. In a lot of cases, they will move those domains when the actual server gets shut down that's behind it. And they're actually stockpiling domains as well. That's one of the things in this particular campaign. We've certainly seen them do that. We've seen November 2nd, they registered hundreds of these things and have been using them ever since. Right? So they're actually doing some of these techniques too. A lot of people use the day-old bread approach, which is if a domain name is less than a week old, I'm not going to trust it. And so they're aging these things. They're doing a lot of cool stuff, and then they're hosting them in different locations too. So you can't necessarily tie in on or key in on the IP address. So lots of different techniques they're using. And this is just one example. There's a lot of stuff going on. Okay, this is a different issue. This actually, this is an email sent to me from a government somebody who works at a government agency in the U.S. I won't name which one. But that was his question, right? Should we just block SU entirely, right? Which you can do very easily with this technology. And my answer is, yeah, probably worth it for you because there's no legitimate. I don't know. There may be a few legitimate content domains on .su, but there certainly aren't ones that a U.S. Agency is going to want to reach out to for the most part. And there's a heck of a lot of malware CNCs being run on .su. Ironically, the same day or the day after that, the Swiss CERT basically recommended doing the same thing on a public blog post that they made. So these are the kind of things you can actually do with this kind of technology really easy. Star.su in block or NX domain, done. So that's kind of interesting. But it has implications, obviously, for TLD operators, right? Because if I can block an entire TLD, just a few weeks ago, we found out the Australian government was blocking .info domains for Australian legislators, which was very unfortunate because there's a lot of really good content on .info that some of the legislators and whatever they call them, parliament members, members of parliament or whatever they call it. What is Australia? Is it parliament or? Parliament, yeah, okay. We're trying to get to, which caused a lot of complaints. So they lifted that restriction, but you can get that. Again, this is kind of a misuse of the technology, right? You're over blocking at that point. So you took too big a hammer to solve whatever that particular problem was, and that was based on the recommendation of the Defense Department in Australia. And one could argue that the Defense Department in Australia shouldn't be talking to much of anybody, I guess, but. Okay, so I'm going to just wrap this up. How are we doing on time here? Oh, I've managed to talk most of my way through my time. Sorry about that. So we have all these issues that seem to be nails. We've got a really effective hammer, but depending on how big or small the nail, you can almost think you've got a really big hammer and there's a really nice looking nail, and there's just some really tiny nails. And if you hold your thumb too close, you're going to hurt yourself, right? If you slam down on that. But this is the genie's out of the bottle on this stuff. People know about it. People are using it. People are asking to use it, I think, in ways that are good and ways that are inappropriate. So I think as a community, we need to be thinking about best practices, about advisories on when and when not to use this kind of technology and techniques as what we do in our network protection schemes, and how we handle it in the ISP level. So that's what I had to talk about. I already had a couple of questions, but those are my thoughts. I want to make sure we're aware of what's going on and making sure we're applying it where it should be and trying to talk people out of trying to make laws to apply it everywhere. So any other thoughts or questions?